Hi, I am Shevin Sam, and today I'm going to do my fourth experiment in OS Lab, and that is CPU scheduling algorithm. I'm urk18cs277, so I'm going to explain about four algorithms today. That is first FCFS, second SJF, third priority scheduling, and fourth round robin algorithm, scheduling algorithm. So to write the program to implement CPU scheduling algorithm to first come first serve, all the four scheduling using C or C++. So two codes have been given, languages have been given. So I'm going to do my four algorithms using using C programming language. So like this is the types have been given over here. So I'll just directly go into the program. So here's my first one, that is like FCFS. So hash include stdio.h, main function gets opened. I'm entering the variables of AT, AT2, BT, EX, sequence, SEQ, RE, WT, and DAT as average waiting time and all that stuff. I'm giving and assigning all the variables with 100 as a maximum size. And then int of Nij, placing all variables of post max is equal to 0, min idle is equal to 0, k is equal to 0, importing the variables that is scanf ampersand d, I'm like modulus d ampersand n, that's the number of processes, the interval time for putting a for loop and then just scanning it, that is 80. And if 82 of I is equal to 80 of I, I'm closing the bracket up. I'm asking for the burst time. They're asking for the burst time using the for loop again, then scanning the for loop variable. I'm sorry, the burst time variable, and then it gets closed. And now I'm going to use start is equal to 80 is equal to 80 of 0. That's why I'm going to start. So for I equal to 1, I is less than n, I plus plus, and I'm going for the if statement, that is start if greater than 80 of I, start is equal to 80 of I. And then print the output sequence, a printf sequence of execution. This is how, so when all the variables are arrival time and the burst time is taken, now it goes with execution. So execution is going to open, it's going to open for loop. For I, I'm going to open for loop I is equal to 0, I less than n, and I plus plus. Opens if max is less than the average waiting time of I. That means max is equal to 80 of I. And if it's not, then close the brackets, max is equal to max plus 1. Execution comes like for loop I equal to 0, I less than n, I plus plus, and k plus plus a constant, and min is equal to max. For j is equal to 0, j less than n, j plus plus. If AFT of j is not equal to minus 1, that means if AFT of j is less than minimum, then minimum gets stored in minimum, the AT of j gets stored in minimum, and position is equal to j. The bracket gets closed. So printf p ampersand d, it's a position. Open the position variable, sequence of k is gets stored in position. If start is less than at the position, means reposition is equal to start. It gets repostponed. Not repostponed, I'm sorry, it will get like replaced. The start variable gets saved into it. And then idle plus is equal to the position minus start. Start is equal to at the position, and bt the burst time of position plus start is getting, they'll both get added and the value gets entered into start. At post is equal to minus 1, x post execution time, that is equal to start. So that's all these functions, and then my printf slash n, it goes for the next line. You'll have feed and for I equal to 0, less than I plus plus, both the functions. That is very important to calculate the waiting time and the average timing. So the printf, this is how my table is gonna come. That's process first, average time, burst time, waiting time, turnaround time, and then it's like you're just printing it and then you're adding all the variables. So if I'm going for it the first, I'm going to run my program. So here I'm going to run my program, and here first I'm going to end the number of process as 5. Number of process as 5. Arrival time I'm going to take it as 35054. Yep. And my burst time I'm going to take it as 4 3 2 oh sorry 2 3 I'm like burst time. I'm so sorry. 4 3 2 1 3. Yep, and here comes my timing program, the waiting time, and here's my average time, the burst time, the waiting time, and the turnaround time all gets function, and the average waiting time is 3.200, and the average turnaround time, I'm sorry, that was the turnaround time, that is 5.800. Now let's go for the next program, and that is SJF. So here SJF, same thing like hash include stdio.h, the program void main, opening them btp wt tat. I'm taking it as all initializing the variables in float these average wait and average turnaround time, and then printf enter number of process and enter the number of burst time. It's all the same. And here, sorting burst time ascending order using selection sort. And selection sort is I'm using temp is equal to bt of I, bt is equal to bt of position, the burst time position gets into the temporary variable. And temp is equal to p of I, the position of variable I, and p of I is equal to p of post, and p of post temp, the p of post, that means p of I gets stored into the temp. So I'm arranging and current the ascending variables. This is a waiting time for the first person. So first process, calculating the waiting time, that is for I equal to 1, I is less than n, I plus plus. We open the braces, wt of I equal to 0. For j is equal to 0, j is less than I, j plus plus. Wt of I plus equal to the burst time of j, means wt of I is equal to wt of I, the waiting time of I, plus the burst time of j. Both gets added and the value gets saved into the wt of I, into the position of variable I, a waiting place, and then total is equal to, total plus is equal to wt of I. Total all gets, like all the wt's of I, the waiting times of I, it's summed up and then saved into the total variable. And here average wait, you're finding float of total of n, and then you're printing the process, how it should come and all that stuff. So I'm just going to do it. This is my SJF program, and then you're taking the average turnaround time, and then it's getting like stored and printed. The average wait turnaround time and the waiting time is all going to get printed. So I'm just going to do it. I'm just going to run the program. Okay, so here is my process. I'm going to take it as 4. Enter my burst time. The P1 is equal to 4, 8, 3, and 7. So here's my table for the waiting time and the turnaround time. Burst time is initial, waiting time and turnaround time is being calculated by the formula given over here, and then waiting time using the formula is getting calculated. Turnaround time, once the formula given over there, behind this it gets calculated, and then the average time has been taken, and the average turnaround time, the total divided by the number of it, it's getting stored over here. Yeah, so here is my SJF program. Now I'm going for my third program, and that is priority scheduling. For priority scheduling, I'm going for hash include std.h. Main function gets opened. I'm opening all the variables again, the same, initializing the variables, the size, and then all the variables that is required. Average wait, average turnaround time is all the same. Take a number of process, enter the burst time, the priority time, and then for I equal to 0, I less than n, I plus plus. For total number of process, initialize 10. For burst time and the priority, first I'm opening of for loop. Then I'm entering printf, p of ampersand d, modulus d, and I plus 1. Burst time, it's getting stored, the burst time of I is getting stored, priority, pr of I. That's how the variable is getting stored. And pi is equal to I plus 1. Now I'm sorting the burst time priority in the process number in ascending order, and that I'm going to use like for of I equal to 0, I less than n, I plus plus, position is equal to I. For j is equal to I. Yeah. So here for j is equal to I plus 1, j less than n, j plus plus. And then if the priority of j is less than the priority of position variable, the position gets is equal to j gets stored into pos. And then again I'm using the selection sort over here, and then temp is equal to pr of I, pr of I is equal to pr of pos, priority of pos is equal to temp. It's into temp, and then the same for burst time of I, and then for p of I, the position. And then I am going for the normal, that is calculating the waiting time. It's all the same, total is equal to total plus wt of I. It's same, and then you're finding the average waiting time. And then printf the process burst time, waiting time, turnaround time, it gets saved in the table, and then the total is getting calculated and divided by n, the total number, and then it prints out the average waiting time and average turnaround time, and it's getting stored over here and return 0. I'm going to close it. So here I'm going to run the program. I'm going to run it. So I'm entering the number of process as 4, and the P1's burst I'm picking as 6, priority as 3. For P2 my burst time is 2, and priority is also 2. And then for my third one I'm taking 14, I'm taking it as 1. Yep. And for my P4 I'm going to take it as 6, and then my 4 as priority. And then here comes my average waiting time and my average turnaround time. Here's my burst time, waiting time, turnaround time, all calculated according to the program. Now next I'm going for the last, and that is round robin. Yep. So here I'm going to explain from the start, that is hash include stdio.h int main, open the braces, in count j and time remain flag is equal to 0, time quantum, that is important in round robin. Int wait of time I'm taking as 0, turnaround time is equal to 0, and I'm initializing the variable in integer variables, in integer type mode. Printf enter the total process, that is n. Remain is equal to n. For count is equal to 0, count is less than n, count plus plus. Enter the arrival time and the burst time for the process number. I'm sorry, I made a mistake here. And then here I'm using scanf, like ampersand d, like at count, average time count, and then scanf burst time, taking the count, entering the time quantum. Okay, time quantum is a variable, initializing it, and printf like process, turnaround time, waiting time. Printing all these three, I'm going to print like process, turnaround time, waiting time. Like for time is equal to 0, count is equal to 0, and remaining is not equal to, if it is not equal to 0, if RT of count is less than or equal to time quantum, and RT of count is greater than 0, that means time plus RT of count, sum gets summed up into time, RT of count is equal to 0, you're taking flag is equal to 1. Else if RT of count is greater than 0, you're taking RT count minus, you're subtracting it from there, and then you're getting saved, and then time plus is equal to time quantum is getting saved or summed up and getting saved into time, the variable. And then you're using an if condition. If RT of count is equal to 0 and flag is equal to 1, before the flag was equal to 0, now it's when flag is equal to 1, remain minus minus, it's getting decremented, and then printf all the functions, wait time is wait time plus equal to time at count minus bt count, the first time, turnaround time plus is equal to time minus at count, flag is equal to 0. If count is equal to n minus 1, count is equal to 0. Else if average time of count plus is less than the time, means count plus plus, else count is equal to 0. Average waiting time and turnaround time is getting it's getting stored, it's getting printed, and then return 0, close the bracket. So I'm going to run this program. So here I'm going to enter my number of process as 4. Yep. The arrival time is 0, 9. second one 1 5 2 3 3 4. Yep, 3 4. I'm giving my quantity time as 5, and then I'm just entering it. Here comes my whole thing. So here is my average waiting time and average waiting time and average turnaround time. So this is the table as shown over here. This is the turnaround time and the waiting time. So here ends my all the program that was for CPU scheduling algorithms. All the 4 algorithms have been done and shown. So thanks a lot.